So if you're building with AI, you know how tough it is to keep up, right? There are new tools, new libraries. It feels like every single month. But what if the core challenges of actually training a model are timeless? Well, let's get into it. And that right there is the key idea. I mean, the tools are going to change, but the actual need to design, run, and interpret your experiments in a super rigorous way, nope, that's not going anywhere. We're going to break down some principles that have been true for a decade, and they'll probably be true for the next one too. So here's what we're going to cover. We'll start by talking about the training challenge itself. Then we'll lay some groundwork for success. After that, we'll dive into running smart experiments, reading the results, and we'll wrap it all up with one final and really crucial principle. Okay, so first things first, let's cut through all the noise about what training even means. Look, whether you're pre-training some monster model from scratch, which, let's be real, most of us aren't, or you're fine-tuning an existing one, the fundamental challenge is the same. How do you separate real progress from just random chance? The good news is these principles will help you do exactly that. All right, this section is so important. This is where the magic really happens. It's not in the training itself, but in the discipline you have before you even press run. Getting this part right is going to save you so much headache later on. And this brings us to tip number 1, and honestly, it might be the most important one of all. If you can't measure your progress accurately, you're not making progress. Simple as that. You're just flying blind. And just having an evaluation set isn't enough. A bad one can send you sprinting in the completely wrong direction. And this spam example, it's the perfect way to see why. So imagine you build your spam classifier. You hit 99% accuracy, and you're thinking, wow, I'm a genius. But hold on, what if 99% of the emails in your test set were never spam in the first place? Well, then a model that literally does nothing but guess not spam every single time would also get 99% accuracy. It's such a classic trap. Okay, so the spam example is maybe a little obvious, right? But the truth is, these kinds of flaws can be incredibly subtle. So subtle, in fact, that one of the most popular academic benchmarks out there, one that was created at Stanford, had a huge hole in it that went unnoticed for years. And this is just wild. Take a look at this. The idea was that the AI had to really understand both sentences to get the right answer. But researchers found a huge flaw. The models were basically cheating. They figured out they could just ignore the first sentence, look for a simple word like not in the second sentence, and guess contradiction. And doing that got them the right answer 67% of the time. The model wasn't learning language, it was just gaming the test. So that whole benchmark mess just goes to show how hard this stuff is, even for the experts. And that brings us right to our next tip. Please, don't make your life harder than it needs to be. Unless you've got a really, really good reason, just don't start from a blank page. The goal here is to stand on the shoulders of giants, right? Not to reinvent the wheel from scratch. Think about it. Fine-tuning an LLM has just a bazillion moving parts. You've got tokenization, prompt templates, different model architectures, optimizers, and every single one has its own set of knobs to tune. Trying to get the perfect mix of all of these from scratch, yeah, that would literally take longer than a human lifetime. Just start with some good code from a reputable paper or from a place like Hugging Face. Now, I know a lot of us, myself included, we start our work in notebooks like Colab or Jupyter, and they're great for a bit, but they have this dark side. It's called hidden state. It's so easy to accidentally run cells out of order or to forget a variable is still hanging around from an hour ago, and that can totally poison your results. A Python script, on the other hand, gives you a perfectly clean, fresh start every single time. And really, that's the bottom line here. For that initial exploration phase, notebooks are a total blessing. But once you get serious about running rigorous, repeatable experiments, they really can become more of a curse. That risk of a tainted run is just way too high. Okay, so we've laid our groundwork. Now let's get into the fun part, the actual art of running experiments in a way that, actually teaches you something. This next tip, this might be the single most productive rule in all of machine learning. Seriously. And I get it, it's so tempting to just bundle a bunch of changes together that you think will help, but trust me on this, it's a recipe for confusion. So let's look at the wrong way to do this. You run an experiment where you lower the learning rate, you add some dropout, and you tweak the optimizer. The results get a little bit better. Great, but which change was responsible? Was it one of them, all of them? Did one of them actually make things worse, but another one made it better? You have absolutely no clue what actually worked. Now, let's look at the right way. You have experiment A and experiment B. They're identical in every single way, except for one thing, the learning rate. Now, when you compare the results, bam, crystal clear. You've learned something real, something you can act on. This is how you make progress.
So, you run your beautiful, clean, single-change experiment. Now what? Well, now comes the moment of truth. You gotta read the results. And the first place you're gonna look? It's almost always your loss curves.
All right, first up, we have the training loss. This is just a measure of how wrong your model is on the data it's currently training on. Yeah, it should definitely go down overall, but do not expect a nice, smooth curve. Because the model is looking at different little batches of data at each step, the line is going to be, well, jiggly. And that's totally normal.
Okay, but the training loss only tells you half the story. To get the full picture, you need a validation set. Think of it like this. It's a small chunk of your data that you set aside. The model never gets to train on it. Its only job is to be an unbiased referee, telling you how well the model is generalizing to new, unseen data. And when you plot these two curves together, that's when the whole story comes into focus. When things are going well, both curves slope down together. It's a beautiful thing. But if you see the training loss keep going down while the validation loss flattens out, or even worse, starts to creep back up, that right there, that's the big red flashing alarm bell. Your model has stopped learning and has started to just memorize the training examples. So this all leads to a really simple but super powerful answer to that classic question, when do I stop training? And the answer is, you stop the moment your validation loss stops getting better. That's it. That's your sweet spot. Pushing the training loss any lower after that point isn't just useless, it's actually hurting your model's performance on new data. All right, so we've got a solid evaluation, a clean setup, a disciplined way to run experiments. We're set, right? Well, almost. None of this matters without our final principle, which isn't a technical one at all. It's all about your mindset. And it's really the simplest tip of all. Be patient. Seriously, your model is almost never gonna work on the first run. It just doesn't happen. Even the transformer, the architecture that basically runs our world now, had a really slow, unstable start until the community figured out the right combination of hyperparameters. So be patient and be skeptical, especially if any tutorial you see out there that doesn't actually prove that their fine-tuned model is any better than the base model it started from. And, at the end of the day, that's the real takeaway here. This whole thing isn't about finding some magic bullet or a secret hyperparameter that solves everything. It's about having a disciplined, patient, scientific process. So now you know the principles. The only question left is, are you ready to actually embrace the process?